I'm going to finish up solving linear systems by substitution with two more examples. Here we have an example 2x plus y equals negative 2 considered with 4x plus 2y equals negative 4. Now I'm going to use the same methodology that I've been using. I don't even know if I said that right. But I'm going to use the same method of solving that I used in the previous problems. If I look at 2x and I wanted to solve this equation for x, I'd have to divide everything by 2. Now 2x divided by 2 would eliminate the fraction, but when I take y and divide it by 2, I'd end up having a fraction. So solving for x is not the best idea. If I solve for y has a coefficient of 1 and I would not have to divide at all. So that's what I'm going to do, is I'm going to solve this first equation for y, which would give me y equals negative 2x minus 2. And I'm going to consider that with the existing equation 4x plus 2y equals negative 4. Now everywhere I see y in the second equation, I can replace it with the expression negative 2x minus 2. So instead of having 4x plus 2y, I now have 4x plus 2 times negative 2x minus 2 equals negative 4. So what I've done is, I'll use a highlighter to show this, I've replaced y with negative 2x minus 2. So here is my 2y, but it's not 2y, it is now 2 times negative 2x minus 2. And I'm going to solve this equation now. 4x, 2 times negative 2 is negative 4x, 2 times negative 2 is negative 4, equals negative 4. Well, the x's cancel out, and I have an equation that says negative 4 equals negative 4. Now, this is an example where the variables drop off. There are no variables. They've been eliminated completely, but now I have a true statement. So the last example, I had a false statement, which meant no solution. When there's no variables and I have a true statement, then that means I have infinite solutions. And we know from the first lesson, solved by graphing, that when you have infinite solutions, you have two lines that are virtually the same line. They're coinciding lines. So we're going to check this by graphing. So I'm going to take the first equation, 2x plus y equals negative 2, and I'm going to graph that line. So I'm going to put a 0 in for x. 2 times 0 plus y equals negative 2. That's going to give me a y value of negative 2. So 0 plus y equals negative 2, that means y equals negative 2. If I put a 2 in for x, I have 4 plus y equals negative 2. 4 plus negative 2 would not work. I'd have 4 plus y equals negative 2. That means y would have to be negative 6. So when I put a 2 in for x, I get negative 6 for y. And I'm going to use a straight edge and connect those 2 points. Now I'm going to do the same thing, but I'm going to use the second equation (4x plus 2y equals negative 4). And again, I'm going to put a 0 in for x. And I have 2y equals negative 4 because the 0 goes away. So y has to equal negative 2. So 0, negative 2. So right there they share that point. That could be the solution because that could be the one intersection point. However, when I put a 2 in, 4 times 2 plus 2y equals negative 4. 8 plus 2y equals negative 4. If I continue solving this and I subtract 8 from both sides, I have 2y equals negative 12, meaning y would be negative 6. 2, negative 6. So when I draw a line going through those 2 points, you see that the 2 lines are coinciding. So this is an example of coinciding lines. Meaning the same line. Which leads to infinite intersection points. Therefore, we have infinite solutions. So just as the algebra suggested and led us to infinite solutions, you can see graphically that that's exactly what happens. So we've had the example in which we had one intersection point, which was 1, 4. We had the example of no solution, where we ended up with parallel lines that did not intersect. Now we have an infinite number of solutions in which we have coinciding lines. And now I'd just like to go and use some algebra working with fractions. Now what I have here in the first equation is 8x minus 7y equals negative 2. So I'm going to come over here and I'm going to show you. If I want to solve this equation for x, eventually I'm going to have to divide everything by 8. Now when I divide by 8, I'll be able to solve for x. However, I'm going to end up with fractions. If I decide to solve for y, because that could be an option, eventually I'm going to have to divide by negative 7, which will leave me fractions. So I'll be able to solve for y, but when I move the fraction over, I'm going to end up with an 8/7 x. So in this case, there's really no way around the fractions if I choose to go with the first equation. The second equation, I would have to divide by negative 2 if I wanted to solve for x. And you can see that although I'll be able to solve for x, I'm going to be left with a fraction with my y term. If I tried to solve for y in the second equation, I would be dividing everything by negative 3 at some point to solve for y, and that's going to leave me with fractions. Because there's no way to get around this, I'm going to clear all my ink. I just need to pick one of the variables to solve and go with it. So what I'm going to do, just because I like smaller numbers and dividing by 2 isn't too difficult, I'm going to solve the second equation for x. So that means I'm going to have to add 3y to both sides. And after I add the 3y to both sides, I divide everything by negative 2. So we end up with x equals negative 3 over 2y minus 5. So now I have an expression that x is equal to. What I'm going to do is I'm going to take this and I'm going to plug it back into the first equation. I cannot plug it back into the equation I just worked with. I just manipulated this second equation, so now I must go back into the first equation and substitute in for x. The reason we're substituting in for x is because this is what x equals. So I have 8 times negative 3 over 2y minus 5 minus 7y equals negative 2. When I distribute the 8, multiplying by 8 is the same thing as multiplying by 8 over 1, which gives me negative 24 over 2y minus 40 minus 7y equals negative 2. This is the same as negative 12y minus 40 minus 7y equals negative 2. Negative 12y and negative 7y are negative 19y minus 40 equals negative 2. I will add 40 to both sides, which leaves me with negative 19y equals 38. I'm not sure if I said negative 19y there or just negative 9y. I meant negative 19y. Divide both sides by negative 19, and we have y equals negative 2. So the first part of the solution is still unknown, but the second part of the solution, which is our y value, is negative 2. So what do we do with this y equals negative 2? Well, there's a few things we can do. We can put it into either the first equation or the second equation. I like smaller numbers, so I'm going to use the second equation, and I'm going to say that negative 2x minus 3 times negative 2 equals 10. Negative 2x plus 6 equals 10. Subtract 6 from both sides. Negative 2x equals 4. Therefore, x equals negative 2 by the division property. So our solution is negative 2x, negative 2, comma, negative 2. If we want to check this, which is always a good idea, we can put these values back in. 8 times negative 2 minus 7 times negative 2 should equal negative 2. It's negative 16 plus 14 equals negative 2. It works in the first equation. Now negative 2 must work in the second equation as well. We have 4 plus 6 equals 10. It indeed works. So our solution stands as the ordered pair negative 2, and you should also be able to recognize x equals negative 2, y equals negative 2 as another way to show your answer. That concludes our systems by substitution, and our next videos that we'll be watching, will include solving systems by the elimination method.